Hello everyone, I'm Ashok. Welcome to the second module in Statistics for Data Science. Alright, in this module, we are going to learn about harnessing data. So that's the module. Okay. Um, so harnessing data is collecting the data, right? So when you repeatedly collect the data, for example, you resampling it repeatedly, there are two methods we actually have broadly. One is with replacement, other one is without replacement. So this is an okay. So if you look at this with replacement, without replacement, let's take an example of a lottery ticket. Lottery ticket, you know, a lottery ticket. You go to nowadays, even if you go to a store, a mall, where you buy something, they'll be giving you some ticket or a token. The end of the month, they'll be taking a lucky draw, and then some of the customers might won some prizes, and that is one of the techniques to increase the sales. So how do you conduct a lottery? So basically we put all of these tickets in a bowl, a pot. All right, then we shuffle it and we take the first one and say, okay, let's say there are three prizes. The first ticket is a third prize winner, and then you take a second one and then you say second prize winner, and then you take the last one who will be the first prize winner, get a bigger prize, of course, right? In this process, what you notice is when you take the third prize winner, this person, this particular ticket is out of the pool, which means if you take another time, there is no chance. Let's say there's a ticket number 103, okay? It's ticket number 103. This is, I don't know, 289, and this is, let's say, 56, some random numbers. This 103 ticket, you've taken it out, and then that's it. I mean, it's not going back again. So the pool, from the pool, it is out, which also means that the 103 ticket who won the third prize has zero chance of winning the second prize or the first prize, because it is out of the pot. And this, we call it as sampling without replacement. Without replacement. So in sampling without replacement, once the data is sampled out, that particular data is not in the pot anymore. There is absolutely no chance, zero chance that you will actually get it again. All right. So opposite of it is actually called as sampling. Pardon my handwriting. Sampling with replacement. In sampling with replacement, so you don't take the data out. So you sample it, it's again in the pool. So you sample it again it's in the pool. So if you have 100 records, even if you sample like five records at a time, the pot remains 100 records. So it is not going to reduce, and that's called as with replacement. So you're replacing back the data and then you are sampling again. Okay, there are two different types, and we will see these applications, especially when you're doing bagging and boosting techniques in machine learning, where you sample the data. These replacement and with replacement, without replacement actually appears. Okay, that's making sense of the data. Second is sampling methods. There are broadly two sampling methods. One is random sampling, other one is non-random sampling. So take a very simple example. Let's say in an organization, you have in a company, you have 10,000 people. Okay, all right. And as a CEO of the company, you would like to know how is your employees. Are they happy? Is there any complaints about the job satisfaction or whatever it is? You want to know. You want to know the survey of the employees to understand the employee satisfactions or the problems your employees are facing. You decided to have a sample size of 100 out of this 10,000. So I want to take 100 from this 10,000. Okay. So there are 10,000 employees, and I would like to take 100 from the 10,000. So I decided to call all the business units heads, BU heads, unit heads, and all the team leads. Okay, team leads, managers, or say team managers or senior managers or managers, and team leads. Basically, I would like to call all the people who are managing the business at different levels. Okay, and let's say they constitute this 100. Okay, do you think you get the proper picture of the organization? Because the whole point of this sampling is to get the sample data which represents the actual population. Okay, so if I put the criteria of only the managers and the people who are leading the businesses or managing the businesses come and participate, do you think you get the proper reflection or the true sample of the actual population? Well, the answer is no, because these people already have certain biases. For example, their work is to keep the people happy and satisfied. So they might be saying you everyone is super happy, which may not be the true condition over there. If you truly want to get the sample, this is called as non-random sample actually. This is called as non-random sample. So non-random sample is not a true sample, and we never take it for any of our statistical purpose. Non-random is useless because it's non-random, means it's not reflecting the true population. It's not a referral sample for your true population. If you want to get a proper true sample, then you should be taking this from this 10,000. We randomly take 100 random sample, which means we can do in many different methods. We simply can put all your employee IDs in a computer program, select randomly 100. You can put it in a box, select 100. You do any random methods, but the goal is to get a random 100, and that's called as random sampling or random sampling, random sample. And this is the true reflection of your actual data. So this data, this 100 people, if you do a survey, if you ask you to analyze the results, it will give you a true picture of your organization. So that's the random and non-random sampling. Okay, so in random sampling, there are several methods. So this is the same thing, of course. There are several methods. This is Cochran's formula. So I'll come back to this Cochran's formula in your next module, which is exploratory data analysis, because it requires a Z, which is your standard value, a Z score, and you need to understand what is Z score before understanding this Cochran's formula. It's a very simple one, so I'll get back to this. Okay, so there are 4 different methods of random sampling. Okay, starting with the simple random sampling, the one we have just seen is a simple random sampling. Out of 10,000 employees, I'm taking 100 randomly. That's a simple random sampling. In simple random sampling, every employee has equal chance of getting picked up. So that's the actual statement of simple random. Each sample, same size, has an equal chance of being selected. So ignore this sample of same size. You simply say out of this 10,000, every person in this 10,000, every employee has an equal chance of getting picked up in this 100 because you are randomly sampling. A simple random sampling. Okay, so let's go back to our women's safety survey. We have done it in the previous module. All right. So let's say we want to collect 3,000 women data. So I want to have a sample of 3,000. Okay, out of how many? 300,000 actual population. Okay, so how do you do this sampling? If you just go out and randomly select 3,000 people from street or some malls or somewhere else, the chances that you get a certain group of people higher. For example, this 300,000 people might constitute various different groups. It can have homemakers who are staying home and taking care of the home, who might be working women like software engineers or something else, who might be construction workers or manufacturing workers, textile workers. Bangalore is one of the areas that's known for textile workers. You also have students and many other categories, right? If you send an email to collect the data, for example, all of the people who are not having access to the email, or they're not educated enough, or they don't have internet access, and they will not be representing the sample. So which means your sample is again not a truly random sample. It is kind of like skewed or biased, right? So how do you how can you get the proper sampling if there are different kinds of groups? Well, what you can do is first you actually divide these groups. In fact, group in English is also called as strata. So strata is an English word for group. So first you categorize the groups into various different, I'm roughly doing it of course, so various different categories. So let's say these are software engineers, or software professionals, software engineers, IT professionals I would say. IT, information technology is more better word. So because that's a bigger segment in Bangalore, so I'm going to take it as one big group, IT professionals. And then we have then we have manufacturing and construction workers, construction and manufacturing and textile, all kind of manufacturing. Then you have students who are still studying, who still fall under women's safety perception survey. So we have homemakers who are staying home and taking care, and we have other groups who are not included in this one. So let's say roughly out of 300,000 people, okay, I have 60,000 over here, and 80,000 over here, okay, and another 60,000 over here, 40,000 over here, okay, and then another 60,000 over here, just for example's sake. I'm just trying to see if it is adding up to 300. So this is 100, this is 120, this is, yes, it's adding up to 300. The reason I'm looking at adding up 300, because if you look at club all the groups, it should represent the entire population. So it should be adding up to the 300. Now I take a proportional sample from each of these data. So from here I'm going to take 600 random sample. Here I'm going to take 800 random sample. Here I'm going to take 600 random sample. Here is 400 random sample. Here it is again 600, because I'm taking proportionally. This is one person sample, so I'm taking 1% from each of these things. If you combine all of this, it becomes 3000. And this is called as, this technique is called as stratified random sampling. This is called as stratified. Strata is just a group, so stratified random sampling. Okay, one of the highly used sampling methods, because by doing this you will not miss out any major group completely, and you have a proportional sample from every single group. We can also devise individual methods of collecting the data for them. For example, for IT professionals, maybe you can send an email. For textile workers, maybe you can go for the hubs of big companies where you have a lot of these employees to speak to the management to get the survey done. Students, we can approach colleges and universities. Homemakers, figure out. So maybe they have a common point, maybe shopping areas and stuff. And others, we have to find it so on. So you can have a different mechanism. Of course, the same data to be collected, same variables, but different methods to reach different groups. It's very effective and more accurate data and more random, and representing all the groups can be collected. This is called a stratified sampling. One last thing to remember, when you're doing a stratified sampling, you should also make sure that this sample is following MESE, which is mutually exclusive, collectively exhaustive. So MESE is mutually exclusive and collectively exhaustive. So what do you mean by that? So if you have different groups you are taking, if there is overlap, okay, then it's not correct, because these people are being counted twice, isn't it? Where they are representing, they are both in this group and that group. So that becomes an invalid grouping. So your group should be mutually exclusive, means there should not be any overlap, something like this. Absolutely no overlap. Okay, and if you combine all of these groups data, it should be collectively exhaustive. In our case, it should together represent 300,000. So that's the reason I was counting the previous slide. It should combine, become 300. So it should be mutually exclusive, so there is no overlap. Collectively exhaustive, which means together it should represent the entire population. And this is an important phenomena. There are many things, but the base level important phenomena you have to take care when you are trying to group it. This is stratified sampling. And the next sampling is your cluster sampling. Cluster sampling, on a, if you want to explain in a simple method, it's very similar to stratified. But if you have too many clusters, too many stratas, for example, too many stratas, let's say you have 30 stratas, 1, 2, 3, and many stratas, and you have 29, 30 stratas. So if you have to do a stratified sampling in 30 stratas, you really have to sample from individual strata, proportional sample, and combine it. It becomes a huge work. It becomes a tedious job and difficult to do it, not practical. So what we do in this case, I'm going to first of all random sample the strata itself. So I'm going to simply take a strata of, I don't know, random sample. So you get some different samples, so different stratas. Something like this. So what I've done, I have first of all sampled the groups itself. I'm not sampling the data, I'm sampling the group itself. Out of 30, I picked up only 5. So I'm ignoring the 25. Randomly sampled, so still it obeys our random sampling philosophy. And then from here, we take a proportional sample, then you make your sample data. This is more or less like your stratified sampling from here, the top portion. But cluster sampling involves first you sample the stratas, and from the stratas you perform a similar stratified sampling method, and this together is called as cluster sampling. Cluster sampling is of course not very accurate as stratified, but it is very helpful when you have a lot of stratas. And why do you do it? The whole purpose of sampling is reduce the difficulty. So if it is permittable, if you can actually have a budget and time and effort and it's practical, then you can actually go and speak to the entire population. The whole point of sampling is to reduce the complexity, still retain the essence of the data. So in cluster sampling, we are extending that philosophy by sampling the stratas first, so it becomes a manageable number of stratas. From there you take a stratified sampling. That becomes your cluster sampling. All right, and the last one, which is systematic sampling. Look at the systematic sampling. Let's say the same organization example I've given before. So you have 10,000 employees, and I would like to take 100 from it for my survey. All right, so for any kind of employee survey, so let's say you have people from all kinds of experience. We have 20 years company, so we have people who have 20 years experience, and with people we have absolutely 0 years or just joined few months of experience. So you have all kinds of people in this. All right, this is 10 years, and this is 5 years, this is, I don't know, 15 years. Okay, so when you're trying to get a sample of 100, it would be nice you have an experienced people from all different things. You have older employees and newer employees. That's how you get the proper sample. How does it matter? Well, it matters. If you see, if someone worked for a long years, let's say 5-10 years in a company, they have a different perspective about the company. They are attached to the company. Okay, if you ask a question to a 10 years experienced employee, so he will be properly do you see any problems with the companies, like any issues in the companies, all right, or anything that can be improved. So a 10 years old employee will be saying something like, well, we had a different client base 5 years ago and North America, and now we've shifted our focus to Europe, and European customers are a bit, I don't know, we are not blending with the culture. These kind of answers you get because they have an overview of the company. They've been there for like 10 years, so they understand the company. They have a feeling for the company. They might hate the company for many reasons. First one is, of course, salary. If you work in one company for long years, your salaries are not that much as you shift frequently. But for many other reasons, you kind of attach with the company. If there is a loss to the company, you will feel that pain because you are attached to the company willingly or unknowingly. It happens if you work for a long years. If you ask the same question for a new joinee, like 6 months left, 3-4 months to 6 months, what are the issues in the company you pursue? He would be coming with an answers like coffee machine not working, lift is slow, and you don't have a TV in cafeteria and stuff like that. So they have a completely different perceptions. So if you sample 100 random sample, there are chances that 100 are coming from a new employees, or 100 are actually the majority of this 100 is coming from new employees, or majority of the 100 is coming from the older employees. This is a problem, because that doesn't give you a true picture of the entire organization. Number of years of experience in company does matter in the perception you have on the company. So how do you handle this? Well, one of the techniques we can follow, every employee has an ID. So the first employee, whoever may be the founder, has an ID of this 00001, and then you have a lot many people, and then you have 00100 and 00200, and then it goes to, I don't know, 10,000, right? So 9900 and then 10,000. Let's say you have 10,000 employees. These are your employee IDs, employee ID number. So what I can say is, okay, you know what, starting from 100, I need every 100th employee. So which means employee whose ID ends with 00. So whom do you get? You get the employees of IDs like 100, 200, 300, 400, so on and so forth, till 10,000. So if you count it, you'll get about 100 employees. Assuming that no one is left in this, the 00 numbers. If yes, we can add a few more people by twisting the formula a bit, right? The benefit of this, because you know that the people who joined earlier get a smaller employee number, who has recently joined get the latest number, which is the biggest number. And no one can influence it, even a CEO or founder cannot influence it, because employee ID is just a next number when you join the organization. So whichever level you're joining, your employee ID number will be the next number. So it's purely random. No one decides what employee ID which employee gets. Because it's random, it qualifies our principle of random sampling. And we have put some formula constraint, systematic way of sampling is every 100. So by doing so, you get an equal uniform sample of all the employees. So you have from the oldest employees to the newest employees, very uniform distribution. And that's the reason it's called as systematic random sampling. Systematic random sampling. And it's a very popular sampling method when you're doing a closed group analysis, like employees or employee behaviors and stuff like that, or any organization or any closed group which has some kind of identification between the data, like employee number and employee ID we have. It's a very standard method because it ensures that you have a uniform distribution of the experience, which is very essential to keep the randomness and also get the proper sample from the data. That's your forced sampling. Systematic sampling is randomly starting from some number and then saying nth number of will join the survey. Right? This will ensure that we still get a random sample, but systematically random. We have a uniform distribution of different experienced people. Okay, these are the most important random sample methods. Right? And then we have different bias methods. So random is perfect. Why do you need a bias sampling? So bias sampling is not recommended because bias sampling name itself implies it's bias. But sometimes it becomes essential or it becomes, bias is more practical. Okay. So there are two kinds of bias sampling. One is convenience sampling, other one is volunteer sampling. Convenience sampling is, as the name says, let's say same women survey, okay. I can actually go around the city and get the data, but I can also do it in my own organization. Maybe my organization is big enough, like you have 10,000 women colleagues I have. I can get the survey done within my organization, all right, and then I can do the offsetting for the other groups, all right. So this is called as convenience sampling because I can access my own colleagues much better than women across the city because they require a lot of different sampling. I can send an internal mail easily. Of course, I'm missing out in the groups, and the people who are working in my company have a different perception. Maybe they are all educated software engineers, right? That needs to be offsetted by using certain methods and techniques, right? So this is not as accurate as a proper random sampling. It's a biased random sampling, but it does give you a very quick data to play with. So convenience sampling, sometimes we do it because it's quick, easy, and sometimes this is the only way we can do it because the actual population random sampling is very difficult to do it from a time and effort perspective. So convenience sampling still works. It's okay. Many academic researchers actually do the convenience sampling. Second one is volunteer sampling. The volunteer sampling is actually same women's survey, women's safety survey. If I call for volunteers, right, you will get some volunteers. They are voluntarily coming and participating in the survey. A small problem with the volunteer sampling, they are random because we are not putting any criteria. They are coming by themselves. But whoever wants to come and participate in the survey, they might already have some strong notion about this topic. Like example, maybe there are a group of people, women, working for women's safety. So they are actually form a NGO kind of thing, and they are actually a strong group of women who are trying to defend women's safety, and they are protest, and actually they get some rules being done and stuff like that. They will be the first people to join the survey because they want to basically raise their voice and use this survey as a forum to communicate. But that's a problem for us because I'm trying to get the non-random sample, a true picture of the entire 300,000 women in Bangalore. A few people who are fighting for the women's rights will not represent the actual population. So this is a very biased people who are joining. You might also get a people who are already affected by this kind of incidences, safety incidences. So they will actually come on forward. They come forward and want to do something. So because in volunteer sampling, people might think this your survey or your sampling as a platform to communicate their message that completely violates our random sample philosophy. So volunteer sampling is you're asking for volunteers to come and attend in your survey. So typically, I won't recommend this for most of these cases because you get a volunteers who already have a strong notion towards the topic you're dealing with, and that's not good for us. Okay, so these are the different sampling methods. Just a quick revision. So we started with saying what is random sampling. First is of course replacement without replacement. I hope you remember that. Random, non-random. Non-random is not acceptable because non-random is non-random. It's not a true sample. Random is what we look at. We looked at several random sampling methodologies. Simple random sampling, which is simple random sampling. Every sample has equal chances. Stratified random sampling, you divide the population into different status or groups and then take a proportional sample, combine it to get your sample. Cluster, similar like stratified, but you first of all random sample the stratas itself and then you do the random sampling, stratified random sampling from there. Systematic, we do it for the employees and organization kind of data where you have employee IDs or any kind of identity. And we have a systematic way of doing this. We can say every 100 employee can participate. So this ensures a uniform distribution of experience in the organization. It's called a systematic random sampling. And then we talked about bias sampling, convenience, as the name indicates, and a volunteer. Okay, so I think that's the last. Okay, one more slide. Sampling error. Sampling error is nothing but we know statistics and parameter from our earlier discussion. Statistic is the summary of a variable of a sample, and parameter is a summary of a variable of a population. So if you take a parameter minus statistic, we call this as sampling error. Sampling error. In the case of women's survey, let's say you have 300,000 population, 3,000 as a sample, and then you have average age of 28 over here, and here you have 26, that's age. So your sampling error of a parameter of a variable age sampling error is equal to 28, which is a parameter. This is actually parameter. Remember the previous module we have discussed about it, and this is statistic. So it is 28 minus say 26, which is 2 years, is your sampling error or estimated sampling error. Okay, there are different methods of collection of data. We already looked at the survey, and census is nothing but 100% survey. Experiment is, we have talked about the energy drink, ABC energy drink, where you actually conduct the experiment in a closed environment, and then the data is basically measured from that experiment. So data is generated from the experiment. That's experiment. Judgment sample or selected, basically it's basically based on typical sample source. We don't use it in data science at all, so it's more for statisticians, and same with the probability samples. So don't worry about that. So that completes your module 2. Module 2 is about harnessing data. So as an end note of this topic, I would like to say harnessing data comes into picture when you're collecting the data from the scratch. So you have some product idea or something which you like to do it from the scratch. You don't have no data, then harnessing data. But typically when you see the projects which we get from the clients, they already have a lot of data. So they simply given access to their databases of relevant databases. You go and actually plunge into the data they have, study the variables, and try to get the variables which is relevant for our project, which for our machine learning project or data science project. So for in the general machine learning projects with the clients and the business, you already have the data, so you don't have to collect the data. So harnessing data does not really practically with the client projects is not really useful. But this is a core knowledge which is required when you're collecting the data from the scratch through surveys and stuff. Okay, hope that is clear. If you have any further questions on harnessing data or any techniques, please drop a message on the comments. So I will definitely respond to it. Also, if you have a bigger question or you want to share some data, you can send an email to the email address mentioned in the description. All right, thank you for watching. Hope you enjoyed the video, and if you like the channel, please subscribe and also click the notification button. I'll see you in the next video.